Good morning, children. Today, in surface areas and volumes part 2, let us continue with exercise problems. Question number 7. Shanti's sweet stall was placing an order for making cardboard boxes for packing their sweets. Two sizes of boxes were required. The bigger box of dimensions 25 cm into 20 cm into 5 cm and the smaller box of dimensions 15 cm into 12 cm into 5 cm. For all the overlaps, 5% of the total surface area is required extra. If the cost of the cardboard is rupees 4 for 1000 cm square, find the cost of cardboard required for supplying 250 boxes of each kind. Here in this question, there are two types of boxes, one of a bigger size and the other one of a smaller size. For the bigger box, we are given the dimensions as length equal to 25 cm, breadth is equal to 20 cm and height is equal to 5 cm. As we want to make the box with cardboard, we are going to find the total surface area. That is, total surface area of the bigger box is 2 into LB plus BH plus LH. Substituting the values, we can see the answer as 1450 centimeter square. For the flaps and all, we can see there is a 5% of total surface area required extra. So we can say the overlaps area will be 5% of 1450, which is 72.5. Therefore, the cardboard used for making a bigger box will be 1450 plus 72.5, which is 1522.5 centimeter square. In the same way, let us find the total surface area of the smaller box, where length is equal to 15 cm, breadth is equal to 12 cm and height is equal to 5 cm. Therefore, total surface area of a smaller box, which is 2 into LB plus BH plus LH, is 630 centimeter square. Again, in this smaller box also we have overlaps, and we can find area required for overlap as 5% of total surface area, that is 5% of 630 equal to 31.5. Therefore, cardboard used for a smaller box is equal to 630 for the total surface area and 31.5 for the overlaps, totally 661.5 centimeter square. As we are making 250 small box as well as big box, total cardboard used for making 250 boxes will be 250 into 1522.5 plus 661.5, which is 250 into 2184, which is 5,46,000 centimeter square. It is given that the cardboard cost for 1000 centimeter square is 4 rupees. So the cost of cardboard for 1 centimeter square will be 4 by 1000 rupees. As we have total cardboard as 5,46,000, cost of cardboard for 5,46,000 centimeter square will be 4 by 1000 into 5,46,000, which is 2184 rupees. Question number 8. Parveen wanted to make a temporary shelter for her car by making a box-like structure with tarpaulin that covers all the four sides and the top of the car. Here, the front face has a flap which can be rolled up. Assuming that the stitching margins are very small and therefore negligible, how much tarpaulin would be required to make the shelter of height 2.5 meter with base dimensions 4 meter into 3 meter? Here, the shelter is in the shape of a cuboid with length is equal to 4 meter, breadth 3 meter and height 2.5 meter. To find the area of tarpaulin required, we can say all the four sides are covered, that is LSA, and the top of the car is also to be covered, that is area of the top. that is 2h into L plus B plus L into B. Substituting the values for length, breadth and height, we can see the answer as 47 meter square. Volume of a cuboid. We know volume of an object is the measure of the space it occupies. As we have learned about the volume of a cuboid and cube in class 8, it is base area into height and area of the base will be length into breadth. Therefore, volume of the cuboid is equal to length into breadth into height, or we can say volume equal to LBH, where L represents length, B is breadth and H is height of the cuboid. For a cube, we can say volume of a cube is equal to edge into edge into edge, that is A cube, where A is the edge of the cube. In exercise 13.5, page number 228, we are going to apply the volume of a cube and cuboid. Question number 1. A matchbox measures 4 cm into 2.5 cm into 1.5 cm. What will be the volume of a packet containing 12 such boxes? Here, length of the matchbox is given as 4 cm, breadth of the matchbox is 2.5 cm, and height of the matchbox is 1.5 cm. Volume of a matchbox, that is L into B into H, is 4 into 2.5 into 1.5, which is equal to 15 centimeter cube. And in a packet, 12 such matchboxes are placed. So we can see the volume of the packet will be 12 into 15, which is equal to 180 centimeter cube. In question number 3, a cuboidal vessel is 10 meter long and 8 meter wide. How high must it be made to hold 380 cubic meters of liquid? We are given vessel is of length 10 meter and breadth of the vessel is 8 meter. But the height of the vessel is not given. But we are given it contains 380 cubic meters of liquid. That means volume of the vessel is 380 meter cube. Substituting the formula for volume of the vessel, that is L into B into H is equal to 380, that is 10 into 8 into height is equal to 380. We can find H is equal to 380 by 80, which is 4.75 meter. Question number 4. Find the cost of digging a cuboidal pit 8 meter long, 6 meter broad and 3 meter deep at the rate of rupees 30 per meter cube. Here we can see a cuboidal pit with length is equal to 8 meter, breadth is equal to 6 meter and height is equal to 3 meter. Therefore, volume of the pit will be L into B into H equal to 144 meter cube. It is given that cost of digging 1 meter cube is rupees 30. Therefore, cost of digging 144 meter cube will be 30 into 144, which is 4,320 rupees. Question number 5. The capacity of a cuboidal tank is 50,000 liters of water. Find the breadth of the tank if its length and depth are respectively 2.5 meter and 10 meter. We are given length of the tank 2.5 meter, depth, that is height of the tank, is 10 meter. Also given capacity of the tank is 50,000 liters, which is equal to 50 meter cube. As we know, 1000 liter is equal to 1 meter cube. That is L into B into H is equal to 50. Substituting the values for length and height, we can see 2.5 into B into 10 is equal to 50, and therefore breadth of the tank equal to 50 divided by 25 equal to 2 meter. Question number 6. A village having a population of 4,000 requires 150 liters of water per head per day. It has a tank measuring 20 meter into 15 meter into 6 meter. For how many days will the water of this tank last? We are given the tank is of length 20 meter, breadth 15 meter and 6 meter. Therefore, we can find the capacity of the tank equal to LBH is equal to 20 into 15 into 6, which is 1800 meter cube. When converting into liters, we can say it is 18 lakh liters of water. This 18 lakh liters of water is used by 4,000 person in the village. And water required by one person in a day is 150 liters. So, the water required by 4,000 persons in a day will be 150 liters of water into 4,000, which is equal to 6 lakh liters. The total water in the tank is 18 lakh and water for 4,000 person a day is 6 lakh. Therefore, we can say number of day water lost in the tank will be 18 lakh divided by 6 lakh equal to 3 days. Question number 7. A godown measures 40 meter into 25 meter into 15 meter. Find the maximum number of wooden crates, each measuring 1.5 meter into 1.25 meter into 0.5 meter that can be stored in the godown. We are given the length of the godown is 40 meter, breadth of the godown is 25 meter and height of the godown is 15 meter. Therefore, capacity of the godown will be 40 into 25 into 15, which is equal to 15,000 meter cube. At the same time, when we are going to arrange the wooden crates in the godown with the length 1.5 meter, breadth 1.25 meter and height 0.5 meter, we can say capacity of a wooden crate will be 0.9375 meter cube. To find the number of wooden crates that can be kept inside the godown will be volume of the godown divided by volume of the wooden crate, which is equal to 15,000 divided by 0.9375. Removing the decimal and cancelling, we can see 16,000 number of wooden crates can be kept inside the godown. Question number 9. A solid cube of side 12 cm is cut into 8 cubes of equal volume. What will be the side of the new cube? Also, find the ratio between their surface areas. We are given the side of a cube is 12 cm. Therefore, volume of a solid cube, which is a cube, will be 12 cube equal to 1728 centimeter cube. We are given the cube is cut into 8 small cubes of equal volume. Let the side of the small cube is x. That means we can write 8 times volume of the small cube, that is x cube, equal to 1728. From this, volume of the small cube is 1728 divided by 8 equal to 260. Therefore, side of the small cube, that is x, equal to cube root of 216 equal to 6 centimeter. To find the surface area of the big cube, that is 6a square, is 6 into 12 square, which is equal to 864. Surface area of the small cube equal to 6 into 6 square, which is 260. Therefore, ratio will be 864 is to 216, which is 4:1. Question number 9. A river 3 meter deep and 40 meter wide is flowing at the rate of 2 km per hour. How much water will fall into the sea in a minute? We are given water flowing at the rate of 2 km per hour. That means in 1 hour, water flowing into the river will be 2 km, which is equal to 2000 meter. Volume of water flowing into the sea in 1 hour will be volume of the cuboid, which is equal to L into B into H, equal to 2000 into 40 into 3, which is equal to 2,40,000 meter cube. Therefore, volume of the water flowing into the sea in 1 hour, that is 60 minutes, is 2,40,000. Therefore, volume of the water flowing into the sea in 1 minute will be 2,40,000 divided by 60, which is equal to 4,000 meter cube.